what I wanted you to plot here was the cumulative frequency, okay, which is the total number of pennies in the cup after each time interval. And as I walked around, I saw a few things, okay. I saw people counting like 1, 2, 3, like the time interval was like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever it was, okay. Well, that would only, like, unless you specified somewhere that there were in 10-second intervals. I guess, I don't know, depending on how your graph turned out, we'll see, okay? I didn't do it that way, so I don't know how it turns out. But the way I did it, because we did the activity together, I plotted on the bottom. I went, this is 10 seconds, 20 seconds, 30, 40, 50, 60. Not that it really matters, it's just a difference of a factor of 10. But, and I counted by 2. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And this was time. Okay, and then up the vertical axis, or Y, right? Number of pennies, whatever it is, we label. Okay, remember, I went back in here and I said, did I say it? Be sure to include all formal components of a graph on your scatter plot. So that includes labeling axes. Obviously, like, you got to put the numbers on, but then also, like, you got your axes labels and also your what? The title of some sort, okay? So along the vertical axis, we went up to a total of 58. I think it worked if I counted by tens again. 10, 20, 30, 40, 50, 60, or sorry, I guess I'm counting by fives. 60, 70. Okay, every box is 5. Okay, now then I went and plotted the data. Okay, so starting amount was 16, so at 0 time I would have started at 16. So right here, and then cumulative frequency means add the number of pennies every time, right? So we went from 16 to 18. So at 10 seconds we would have had 18 pennies in the cup, and then 18 and 5 make 23. Over one. Okay, 30 makes, that's 38. Okay, and then 40, 40, and then 44, and 49, oops, 49, 52, and 62. Jeez, what happened here? I made a mistake. Oh God, it's gonna be one of these days, eh? $23, $28. All right. So once you got your data points drawn, draw the line of best fit. Okay. Now, when I drew my line of best fit, it came out to be something like this. In this neighborhood, let me see here. Something like that. Okay? And I called the y-intercept 10. Okay? Everybody's line of best fit is going to be a little different. Okay? Because it's an estimate. It's a line of best fit. And each of you are going to draw a different line. And so when you go to actually do the calculation, it's going to be a little bit off. Okay? So what I did is I called the y-intercept because I thought it was close enough. Called it 0 and 10. And then I went and found a different point on the grid, or somewhere on like a different, a point that the line went through, a nice coordinate, like a right through grid line. Okay, or just close to one as I could find. And it turned out that I was looking maybe 20 and 21, I called one. So just another point. Called it 20 and 21. Okay. Because it's a line of best fit, it's kind of a separate thing from your data. Okay, so don't go to the data and pull a set, like a point off the data set. It's a line of best fit. It's different. You have a different set of data points for that line of best fit than the actual raw data. Okay? So try and find something on the line of best fit. That's a nice point, and then you can apply your give me the equation of the line skills from last unit. Okay? By that I mean you can find m by going y2 minus y1 over x2 minus x1. That's going to equal 21 minus 10 over 20 minus 0. It's 11 over 20 is m. Okay? And then you can rewrite your equation of line of best fit. You know the y-intercept is 0, 10. So b is 10. And you know m is 11 by 20. There's your equation of the line of best fit. Okay? Does anybody have any questions to that? I'll jump down to the last question, answer it, and then we can come back to the one in the middle. Okay? The one in the middle is kind of, we just talk about it. Okay? The very end of this wants you to use that line of best fit to say, okay, well, how many pennies would have ended up in the cup after 120 seconds? Okay? And then there's, is this interpolation or extrapolation? Okay? So let's go. We'll go down. We're going to use our equation of the line of best fit. Okay, I'm going to rewrite it down here. And then I'm going to take, remember what's on our x-axis up on our graph? We put time. So I'm going to take 120 seconds and plug it in for x. Okay? And when you run through that, you should see something like 1320 over 20 plus 10, which is 66 plus 10, which is equal to 76. Now, one final part. Is it interpolation or extrapolation? Ollie?
I wasn't here when this happened, so I don't know what the test is talking about. For the penny toss.
We were in, oh, okay.
For talking about penny toss.
Okay, all you had to do is plot the data. So I can help you with that in a sec. We just did an activity after the test on.
Okay, I
Friday.
haven't answered this, so can I step outside?
Yeah, that's all right. If you want, yeah. It doesn't matter, Ollie. It's okay. It's up to you. Okay, I can help you with it in a sec. Interpolation or extrapolation? What is it? Just kind of like pulling on drawstrings today. Like thinking back to when Mr. Ingman was here. Gotta remember what these two words mean. Which one is it? If everybody's gonna sit and stare at their phones and not like, or just twirl their thumbs, like I'm just not gonna answer it, and then it'll be on you to figure it out. Yes.
Extrapolation.
It's extrapolation. Why is it extrapolation?
Because it's outside of the data set.
Outside the data set means it's extra. Okay, so it's extrapolation. That's how I remember that. Interpolation sounds like inner, inside. That's, you can make inferences about data sets if it's within the data set. But 120 seconds lies outside of what we collected as data. So it's extra, so it's extrapolation. Okay? Everybody happy? Okay, well, we'll talk about this last one. All right.